Okay, right. Right, part C. This is the bit that's difficult. And we know it's going to be difficult because it's worth 7 marks, yeah? This is the current model, but they've just changed some bits and pieces. So let's have a look at what they've changed and see what consequence that has for our diagram. The car is moving along the road when the driver sees a set of traffic lights have turned red. Problem. Going to have to stop. He reduces the force produced by the engine to 0. Okay, so this was previously 1,200 newtons pulling him forward. That's now become 0. Okay, I imagine that's going to have consequences for the acceleration. He reduces the force produced by the engine to 0 and applies the brakes. Okay, the brakes produce a force on the car of magnitude F, and the car and the trailer decelerate. Okay, so a force of this. Okay, right. I'm just going to read the next part as well, because I think the next part of the question is probably going to help me. Given the resistances to motion are unchanged and the magnitude of the thrust, okay, that's weird because we've been dealing with tension before and now we're dealing with thrust, in the tow bar is 1,000 newtons, find the value of F. Right, try and get my head around this. So this car's slowing down quickly. Right, that means that the acceleration is going to be changing, so I can't keep that acceleration here. I'll just call that A for now, yeah? Given that the resistance to this, the brakes produce and the car and the trailer decelerate. Okay, so it's going to be going forward with A, and because it's decelerating, I'm expecting that value of A to be negative. Now, the force is acting against it, isn't it? Yeah, the force is acting against it. So there's a force acting on the car because the brakes, it's acting against it. So this force, sorry, let me just move these things here. Can I? Yeah. So there's a force acting against it. And it tells me the magnitude of that force, sorry, that's a terrible arrow, is, don't know, F. Now, if I look at this, think about what's happening. Think about what would happen if it was coming up to a traffic light. So I'd have this car and then it'd slow down. If you think about it, the difference is that this is the trailer as it comes up is actually going to be pushing into it. And that's the difference between thrust and tension. Thrust is a pushing force and tension is a pulling force. No longer is the car pulling along this trailer. If I think about it, the thrust is actually going to act like this. If you think about it, it's going to be pushing into it. And if you think about it, that tow bar is actually going to be pushing this car as it slows down, isn't it? Because that momentum of it's just going to carry on and sort of push it up against there. Yeah. So thrust is the opposite of tension. Tension is pulling, thrust is pushing. Okay. Now I'm going to resolve for the car. Let's resolve for the car. Could look at the whole system, but because it tells me that the thrust is 100 newtons, I think I'm probably going to have to use this in my calculation. There probably is a method whereby I could look at the whole system, but for now I'm going to break it down and look at the two individual things. So let's look at this. I'm going to look at the car. Then I'm going to resolve the forces for the car. Well, what forces are acting on the car? Let's resolve it in this direction. So this is positive. Okay, so well, I haven't got anything acting in that direction, so there will simply be nothing there. So, oh, hold on. Didn't draw that very effectively, did I? So let me just look at these things. I was wrong when I said that because there is a force going in this direction now. There's T, isn't there? T is the only one going in that direction, so let me call that T. Then what's going in the other direction? Well, the force is going in the other direction. And it told us in the question that all the other things stayed the same given the resistance to motion are unchanged. So this 200 is still applicable. Is equal to the mass of the car, because I'm looking at the car alone, times acceleration. Now, if I wanted to, I could rearrange that. In fact, did they give me something in the question? Yeah, they did, didn't they? They told me that the thrust of the tow bar is 100 newtons. So I've actually got another value here. That's great. So I'll put that in. 100, take away F, take away 200 is equal to 900A. Then what I'd just quite like to do is just rearrange. So I'm just going to put F here. So I now have F equals minus 100, because that's what 100 take away 200 would be, minus 100 and minus 900A. Well, that doesn't help me, has it? Because it's got one unknown, F, and another unknown, A. Right, okay. Well, I'm thinking, and this is why I went into a lot of detail on part A, I know that if I look at these two things, I'll have two unknowns, and then I'll have essentially a simultaneous equation. Sorry, not thrust, I want to call that trailer. So now I'm going to look at the forces acting on the trailer. I'm going to act in the horizontal direction. What have we got acting on the trailer? Let's get my dashed line, be real careful with it, looking at only the forces acting on the trailer. Right. This time there is nothing acting in this direction. It's just acting in this direction. So I'm going to call that minus 100. That's terrible. Minus 100. It's not much better. Take away T is equal to the mass of it, which is 300, times the acceleration. Remember, I don't know what the acceleration is because I can't use 0.75 because it's changed, because the whole system's changed, because now the car's decelerating as it comes up to the lights. But what I will plan to do is now, hold on, this is actually quite nice if I think about it, because I've got minus 100 minus T, so equals 300A. I'm tumbled the thrust if we remember in the question. Ah, this is looking good. So this will give me minus 200 over 300 essentially. So actually if I simplify it, I know that the acceleration is simplified is minus 2/3. That makes sense. I know it's going to be negative because it's decelerating. 2/3 sounds reasonable. Now I've got A, I substitute this value of A into my equation that I had for the car. So now I'm going to substitute sub A equals minus 2/3. So I've got minus 100 minus 900. Don't get confused with the negatives, you must put them in. Minus 2/3 equals F. And if we do it all properly, we should have got F equals, what was the answer to the question again? That would be minus 100, 2/3 of that would be minus 600 minus 6. Yep, brilliant. Okay, so F would be F would be 500 newtons. In hindsight, remember I said it doesn't matter what way you call positive. It might have made sense to call the R, resolve it in the other direction, then when you would have had all positive calculations. But it doesn't matter either way. Hopefully that explanation makes sense. I feel like that was a bit more garbled than the other one, guys. And you also saw some random pictures of some white figures carrying a sofa for no reason whatsoever, so I understand that's confusing. Please have a look at that and then let me know if you have any questions. Thanks a lot for all your hard work, guys. Keep it up.